This is SpaceTime, Series 26, Episode 41. Coming up on SpaceTime, a second coronal hole discovered on the Sun in a week. Sweden launches a rocket to study the Northern Lights. And NASA's new PACE spacecraft to study the world's carbon cycle. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
For the second time in a week, a huge coronal hole has been detected on the Sun. Coronal holes are regions on the Sun's visible surface which appear darker in X-ray images. They can extend from the Sun's equator to its poles, or even in some cases from pole to pole. They were first noticed in X-ray images taken by sounding rockets back in the 1960s, and they were also identified in observations taken by the Criss-Cross radio telescope near Badgerys Creek in Sydney's outer western suburbs. However, they were seen far more clearly in images taken by crews aboard NASA's Skylab space station in 1973 and 74. By the way, that Criss-Cross radio telescope we told you about? Well, it doesn't exist anymore. It was the world's first cross-grading interferometer and the first radio telescope to provide two-dimensional daily mapping of the Sun. It was constructed by the CSIRO near Badgerys Creek in 1957 and operated at a frequency of 1420 MHz. Then in 1959, an 18-metre parabolic dish antenna was installed adjacent to the Criss-Cross array. That resulted in the world's first high-resolution compound interferometer, and it was used to survey discrete radio sources. During the 1970s, the FLIRS synthesis telescope was developed by adding 6 standalone 13.7-metre parabolic dish antennas. When used in conjunction with the Criss-Cross, this became one of the world's most powerful radio telescopes, and it was used for detailed studies of large radio galaxies, supernova remnants, and emission nebula. Sadly, the facility was forced to close in 1988 as Sydney's suburbs continued their westwards expansion. So, what's a coronal hole? Well, the solar corona is the outer atmosphere of the Sun, extending from the solar surface out into space. It's a region which is difficult to observe, being only really seen during solar eclipses or with special equipment. A coronal hole is a large region within the corona which is less dense and cooler than its surrounds. These coronal holes can appear at pretty well any time during the Sun's 11-year solar cycle, but they're usually far more common during the declining phase of the cycle. And that's what makes this so interesting, because right now, solar activity is increasing as the Sun climbs towards solar maxima, which will happen in 2025. That's the peak of the Sun's solar cycle, the point when the Sun's magnetic field changes polarity, with the North Pole becoming south and the South Pole flipping to north. Coronal holes occur when the Sun's magnetic field is open to interplanetary space. Conversely, in regions where the solar magnetic field loops back into the Sun forming arches, X-rays and ultraviolet images show bright areas. The brightest points in these images are generally the top of magnetic loops or arches. So, the regions of open magnetic field lines are also found to be the regions where the corona has the lowest density compared to where magnetic field lines are closed. The open configuration of the magnetic field lines in coronal holes allows particles to escape, and it's found that these holes are also sources of high-speed solar wind streams. The solar wind is the constant flow of charged particles streaming out from the Sun. These particles usually comprise protons, that is, the ionized nuclei of hydrogen atoms, but there are also lots of electrons and helium nuclei there as well. When the particles from these streams hit the Earth, they can trigger geomagnetic storms. At times of high solar activity, geomagnetic storms are generally the result of coronal mass ejections intersecting the Earth's orbit. But at times of low solar activity, coronal holes are a far more common source of geomagnetic storms. Because coronal holes can last for several months, it's often possible to predict the occurrence of this type of geomagnetic disturbance as the high-speed stream sweeps past the Earth with each solar rotation. Think of it like a rotating garden sprinkler. Unusually, these latest holes have been forming closer to the Sun's equator than typically expected. This week's second coronal hole delivered spectacular auroral activity, even visible as far north as southern Australia. Although the second coronal hole is big, the one earlier in the week was even bigger. This week's two coronal holes came as the Sun emitted a strong solar flare, which was detected by NASA's Solar Dynamics Observatory spacecraft. Solar flares are powerful bursts of energy. The flares and solar eruptions can impact radio communications, electric power grids, navigational signals, and even pose risks to spacecraft and astronauts. The flare was classified as an X1.2. X-class flares are the most powerful type of eruptions on the Sun. This is SpaceTime. Still to come, Sweden launches a sounding rocket into the Northern Lights, and NASA's new PACE spacecraft to study the world's carbon cycle. All that and more still to come on SpaceTime. Well, with all the space weather activity going on at the moment, it's not surprising that scientists in Sweden have launched a sounding rocket to study the spectacular auroral displays which have lit up the night skies at higher latitudes in recent weeks. Curtains of green, blue and red shimmering lights have been reported as far south as Arizona and New Mexico, as the aurora borealis, a northern light, shines in full bloom following a series of solar flares and coronal mass ejections which have been ripping across the surface of the Sun in recent weeks. Now, as mentioned earlier, these auroral lights are caused by charged particles streaming out from the Sun. When they reach the Earth, they slam into the planet's magnetosphere, making it wobble like jello. As the ionized particles penetrate deeper into the ionosphere, they travel along the Earth's magnetic field lines towards the north and south magnetic poles, in the process colliding with oxygen and nitrogen atoms and molecules, causing them to excite, emit photons, and glow. At altitudes above 300 kilometers, these lights appear a reddish brown. That's thanks to collisions with single oxygen atoms in the Earth's upper atmosphere. Lower down at altitudes around 100 kilometers, these collisions instead create a greenish hue, while the glow turns a whitish yellow beige when nitrogen is mixed in with the oxygen. The researchers at the Swedish Institute of Space Physics launched their sounding rocket from Sweden's Strange Space Centre in the country's far north, releasing barium from aluminium cylinders at altitudes of 100 to 200 kilometers. The experiment produced waves of greenish-white lights in a 200-kilometre radius above the northern Swedish town of Coronal, in the process blocking out the real aurora borealis for a short time. The research was designed to help scientists improve near-space weather forecasts in order to better protect satellites and critical infrastructure. Strange has already seen the launch of more than 600 suborbital sounding rockets, and that number is expected to grow dramatically with the opening earlier this year of the new spaceport Strange, which expands the facility's launch pad capabilities to include orbital rocket launches. The new complex is designed to serve as a complement to the European Space Agency's Kourou Space Centre in French Guiana. This is SpaceTime. Still to come, NASA's new PACE spacecraft to study the world's carbon cycle, and later in the science report, researchers develop a new type of oxygen-ion battery. All that and more still to come on SpaceTime. Whether in plants or animals, greenhouse gases or smoke, carbon atoms exist in various compounds as they move through a multitude of pathways within the Earth system. To study this carbon cycle, NASA have developed a new plankton, aerosol, cloud, ocean, ecosystem or PACE spacecraft which will launch in January. It's designed to peer down on Earth from orbit to see the many forms of carbon in a way other satellites have never been able to do before, by quite simply measuring colours not previously seen from space. PACE project scientist Jeremy Waddell from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says the new spacecraft is standing on the shoulders of giants. The problem is these earlier spacecraft, including some current ones, are limited in how many colours of the rainbow they can actually see. PACE will orbit the planet at an altitude of 676.5 kilometres, monitoring the Earth's complex carbon web. From PACE's perch in space, one of the nearest forms of carbon to be detected could be wispy plumes of smoke and ash rising into the atmosphere from forest fires. Carbon's a key building block for life on Earth, including plant life. When burned, the vegetation's carbon-based molecules transform into other compounds, some of which then end up as ash in bushfire plumes. The instruments on PACE will be able to monitor these smoky clouds, as well as other atmospheric aerosol particles, measuring their characteristics, including the relative amount of smoke in different locations. Combinations of these measurements, made by PACE's two companion polarimeter instruments, and detailed colour measurements of the smoke made by the Ocean Colour Instrument, will help scientists clearly identify exactly what's being burnt. That's right, when it comes to ash, it appears there really are 50 shades of grey. Peering through the smoke particles and other aerosols, PACE will also tell scientists about the health of terrestrial plants and trees. Even after devastating wildfires, fresh green plant life begins to grow and thrive. With more spectral bands and colours seen from the upcoming satellite mission, scientists will be able to better understand exactly what types of plants are recovering from fires and in which sequences. In a time when the Earth's experiencing unprecedented climate change, scientists need to be able to understand exactly how global vegetation is responding to its changing environment. PACE will be able to monitor the different shades of colours in different vegetation, and as well as telling different species apart, plant colour can also be an indicator of health. Just as houseplants begin to fade to yellow if they haven't been watered enough, plant life around the globe also changes colour as it experiences stress. Healthy plants take up carbon in the form of carbon dioxide as part of photosynthesis, while unhealthy plants that can't complete photosynthesis leave carbon roaming around the atmosphere. Given that carbon dioxide is a major greenhouse gas, these measurements also play a significant role in understanding climate change in greater detail. For the first time, scientists will be able to look down at changes in the health of plants over the entire planet, dramatically improving their understanding of how ecosystems function and how they're responding to stress. PACE will also study vast expanses of water in order to measure phytoplankton and even differentiate between different phytoplankton species. Phytoplankton are small organisms that live on the surface of ocean, rivers and lakes. They play a crucial role in the food chain and in the global carbon cycle. But each type of phytoplankton provides a different pathway in the expansive web of routes that carbon can take, all depending on the characteristics of the plankton involved. One pathway could ultimately lead to carbon becoming food for a larger species, while another may lead to carbon becoming waste, sinking deeper into the ocean. Scientists conducting fieldwork have found that different types of plankton vary slightly in colour and have identified these phytoplankton on small scales. PACE's ability to measure the full spectrum of colours will help scientists tell the difference between different phytoplankton species on a global scale. This report from NASA TV.
Between September 2019 and March 2020, wildfires killed billions of animals and decimated more than 200,000 square kilometers of Australian forest, an area larger than the size of Nebraska. Some thousands of kilometers away in the Southern Ocean, massive algae blooms covered a surface larger than the area of Australia itself. Just how are these wildfires and ocean blooms connected? To untangle that, we look to the carbon cycle. The carbon cycle is the flow of carbon between reservoirs in the atmosphere, plants and animals, land and ocean. It's one of the key processes that keeps life sustainable on Earth. And at the heart of all this are land plants and aquatic phytoplankton. On land, most carbon is stored in forests. Here, plants absorb carbon dioxide from the atmosphere into their cells. With energy from the sun, plants combine carbon dioxide and water to form carbohydrates, such as sugar, and oxygen through photosynthesis. In this process, carbon dioxide is converted to carbon-based cellular material. Carbon stored in those plants can be transferred when animals eat the plants die and decay, or in the case of Australia, fire consumes the plants. And once again, carbon-based cellular material becomes carbon dioxide that ends up in the atmosphere. If we look to the ocean reservoir, carbon dioxide is also absorbed by phytoplankton, microscopic organisms that convert carbon dioxide, water, and sunlight into carbohydrates like sugar, and oxygen through photosynthesis. Carbon dioxide released into the atmosphere eventually becomes available for aquatic photosynthesis. In general, any change that shifts carbon out of one reservoir puts more into other reservoirs. But photosynthesis also requires nutrients such as nitrogen, phosphorus, and iron. Without the right proportions of these nutrients, photosynthesis doesn't happen, which can be seen in the iron-limited parts of the ocean, such as far offshore of Australia. Atmospheric aerosols released by fires, however, contain carbon as well as other nutrients essential for plant growth, like iron. When these aerosols are deposited on the ocean's surface, these nutrients become available for photosynthesis. This iron from the Australian wildfires is now thought to have stimulated the massive Southern Ocean phytoplankton blooms of such magnitude that they converted an almost equivalent volume of carbon dioxide released by the fires into carbohydrates and cellular material. And here is why having a vantage point from space is crucial. From satellites, we can observe how the movement of carbon changes when large-scale events like wildfires occur. The connection between the Australian wildfires and Southern Ocean bloom could not have been made without satellites. NASA's Plankton Aerosol Cloud and Ocean Ecosystem, or PACE, mission is specifically designed to better measure parts of the atmosphere and ocean connection with unprecedented resolution. PACE's instruments will shed new light on the composition and distribution of these massive mixtures of tiny aerosol particles and aquatic microorganisms. On board are two polarimeters, instruments that measure specific angles of light reflected, which, for example, allows researchers to tease apart the specific type of aerosols in these kinds of massive fire events. PACE's flagship sensor, the Ocean Color Instrument, or OCI, will cover vast swaths of the ocean, measuring concentrations of photosynthetic pigments, allowing researchers to decipher the different types of phytoplankton.
With an instrument like OCI, where you're measuring this full spectrum of color, all the colors of the rainbow you can imagine, we can start teasing apart the species and the different functional groups and different communities that exist.
The data from PACE will help define those communities, allowing for clearer connections within the reservoirs of the carbon cycle. These fires emitted a huge amount of carbon and other aerosols into the atmosphere, with some estimates suggesting volumes greater than Australia's annual emissions from fire and fossil fuels combined. Those aerosols contained essential nutrients that are thought to have stimulated the rapid growth of phytoplankton in the Southern Ocean. And these kinds of connections can have big impacts.
It's really important to know where the carbon is going and where your food source is going. This is important for not just climate studies, but food security.
The fires that tore through Australia are just one example of how Earth systems are linked in ways we're only beginning to fully understand. With data from PACE, we'll get a clearer picture of carbon as it links land use and fires, atmospheric aerosols and marine communities, and ultimately improves the data we put into climate models.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Scientists have developed a small molecule drug that prevents weight gain and adverse liver changes. The findings, published in the journal Cell Reports, claims the drug was discovered after researchers began exploring how magnesium impacts the energy-carrying molecule adenosine triphosphate, or ATP, which fuels metabolism. Magnesium is the fourth most abundant element in the body after calcium, potassium, and sodium, and it plays many key roles in health, including regulating blood sugar and blood pressure and building bones. But researchers studying mice found that too much magnesium slows energy production in the mitochondria. Mitochondria are the powerhouses of cells. The researchers found that by deleting the MRS2 gene, which promotes magnesium transport in the mitochondria, scientists were able to promote more efficient metabolism of sugar and fat in the mitochondria, and that resulted in skinnier, healthier mice. They also found that liver and fatty tissue showed no evidence of fatty liver disease, often a complication related to poor diet, obesity, and type 2 diabetes. The new drug, which scientists are calling CPAC, accomplishes the same thing by restricting the amount of magnesium transfer into the mitochondria. Meanwhile, a new study by the Australian National University has found that more magnesium in your daily diet leads to better brain health as you age. A report in the European Journal of Nutrition found that an increased intake of magnesium-rich foods, things like spinach and nuts, can also help reduce the risk of dementia, which is the second leading cause of death in Australia and the seventh biggest killer globally. The study of more than 6,000 cognitively healthy participants in the United Kingdom aged 40 to 73 found people who consumed more than 550 milligrams of magnesium each day had a brain age that was approximately a year younger than their biological age by the time they reached 55. That's compared to somebody with a normal magnesium intake of around 350 milligrams a day. The study found that a 41% increase in magnesium intake could lead to less age-related brain shrinkage, which is associated with better cognitive function and a lower risk or delayed onset of dementia in later life. Scientists have developed a new type of battery, the oxygen-ion battery. A report in the Journal of Advanced Energy Materials claims the new oxygen-ion battery can be extremely durable, does not require rare elements, and solves the problem of fire hazards which are prevalent in lithium-ion batteries. That's because the oxygen-ion battery is made out of incombustible ceramic materials. However, there is a problem. It doesn't allow for the high energy densities of their lithium-ion battery counterparts. The new battery concept isn't intended for smartphones or electric cars because the oxygen-ion battery only achieves about a third the energy density of lithium-ion batteries, and also because it runs at temperatures of 200 to 400 degrees Celsius, a little bit warm for your pocket. But its storage capacity doesn't decrease irrevocably over time. It can be regenerated and thus may enable an extremely long service life. The research team think their new oxygen-ion battery could be an excellent solution for large energy storage systems, such as those needed to store large amounts of electrical power from renewable sources when the sun doesn't shine and the wind doesn't blow. A new study has found that teens who have permission from their parents to drink alcohol at home are likely to drink more alcohol and have a higher chance of being harmed by their alcohol consumption. The findings, reported in the Journal of Drug and Alcohol Review, show that around 28% of 16 and 17-year-olds were allowed to drink at home. Among that group, 77% had consumed alcohol over the past month, compared to 63% of those who drank without permission. The researchers say the two groups actually drank about the same amount of alcohol. However, 23% of those who had permission to drink alcohol wound up experiencing alcohol-related injuries, violence, or a hangover, impacting their work or school, compared to just 17% of kids who weren't allowed to drink at home. Apple has just released their latest software update. iOS 16.4 fixes a bunch of bugs and offers a range of new features. With the details, we're joined by technology editor Alex Zaharov-Reutt from itwire.com.
All the new Apple devices have received their update, iOS 16.4, iPadOS 16.4, tvOS, watchOS, macOS, HomePodOS. So if you've got any of those devices, obviously it's a good time to update. It's always a good time to get Apple updates because they normally fix various bugs that are in the system, which is always a good thing to clean up. We spoke last week about the Google Chrome bugs that you should update your version of Chrome straight away, especially if you've got an older device you haven't checked. I mean, a lot of these updates are meant to be automatic, but they don't all happen at the same time because that would be hundreds of millions or billions of devices trying to get to Apple update servers. And of course, that would be the equivalent of a denial of service attack should that actually occur. But probably the standout new feature, at least for the iPhone, is a new voice isolation mode. So this is where your voice will become much clearer when there's background noise, like maybe your neighbors are trying to chainsaw some trees down, or you've got someone vacuuming in the same room as you. Normally you'd be telling them to be quiet and to turn that off.
Yes,
but with
that's
the
the way
voice,
we say it. Be quiet, please.
Yes, well, we'll probably say something else. But what you need to do is you need to put your finger where the battery symbol is on the iPhone 10R or above, and I think the iPhone SE second edition also has this feature that you've got to swipe up for that because it's the old home button version. But you swipe down on most of the new iPhones and you tap on the mic mode, which says voice isolation. In fact, we are now speaking in this voice isolation mode because we are not speaking on FaceTime, which is something that we would normally do. And I remember when this first came out, it was earlier in the iOS 16 cycle, I think when iOS 16 first came out, and it was available only for FaceTime audio and FaceTime video calls. You could have the microphone set to normal, where you'd hear normal sounds. You could set it to voice isolation, so once again, just focusing on your voice. And you could also set it to wide spectrum, so if you were somewhere where you wanted people to really hear all of the noise around you, maybe you're in a crowd or there's a waterfall or there's some reason to hear that extra sound, the FaceTime calls can do that. Now, the standard phone call to Android phones and to older iPhones and to landline phones, well, that now has this voice isolation mode, and you should definitely give it a go. And you can even test it out by getting a hairdryer, for example, putting it next to you. Sadly, I don't have one here right now, but putting it next to you and then turning the voice isolation mode with the hairdryer still going, and you should only hear your voice. So that is the killer feature. That is actually improving phone calls, something that's pretty rare on phones. I mean, we did have HD voice from phone to phone on networks like Telstra and other networks that have switched that on, where you would get a high definition voice even though you were making a phone call, but that didn't really have any noise cancellation sort of features. And in fact, iPhones did have noise cancellation of a sort in the past. For the iPhone 13, they for some reason got rid of it, and at first people thought, oh, this is just some bug, the microphones are still there. They never actually brought that back until now with this voice isolation feature, which makes all the difference. So definitely check it out for your iPhone, your Mac OS, where there's some sort of SMB bug that is fixed. For the watch, if you were to try and mute your alarm whilst you were sleeping, there was a bug that would sort of mute the alarm completely, and then you would miss your wake up window and you'd be late. There's new emojis, various things, but this is an important update, even if just for the improved phone calls alone, and race out and get it as soon as you can.
That's Alex Zaharov-Reut from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to SpaceTimeWithStuartGarry.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGarry on Twitter, @SpaceTimeWithStuartGarry on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.